Okay, jumping ahead this time to question number 5 of the assignment. This is where the problems themselves start to change a little bit. This time, instead of starting with an exponential, we're starting with a logarithm. So um, let's see here. The logarithm, when written with a base of 2 and a number to be evaluated at x plus 3, this unknown is a problem. We can't really evaluate the logarithm here. But if we rewrite this logarithm as an exponential, if we just switch the formats, then we should be able to handle this either with a basic or a more advanced calculator. So let me copy this problem down. This is number 5, and it said log base 2 of x plus 3 equals, I believe it was 4. Let me double check that. Log base 2 of x plus 3 is 4. All right, so again, this isn't something that we can type into the calculator as it sits, so let's rewrite. And if you remember, as a logarithm, we can follow this loop rule to rewrite it. If we start with the 2, raise it to the exponent across from the equal sign, 2 to the 4th power, that would be equal to x plus 3. Now here again, this expression is just a number. 2 to the 4th power is some number. And as long as we can figure out what that number is, mentally or with a calculator, we can take that number and then do with it what we need to get x by itself. In this case, to get x by itself, we'll simply subtract 3 from both sides. And what we're left with is whatever 2 to the 4th power is minus 3, and that's equal to x. I think this problem is a little bit different than the others, where we don't have to type an exact answer and then an approximate result. We just go ahead and provide the answer as it is. So I'll go to my basic calculator and obtain that. So I'll type in 2. In this calculator, this key here represents exponent. So 2 to the 4th power, and I will press equals, but I'm not going to clear my calculator yet. So I know that 2 to the 4th power is equal to 16. Subtract 3 from it, and we've got an value or a solution of 13 for this problem. So if I jump to MathXL, yep, there is a solution. It says to simplify answers, include any radicals. Remember, radicals are square roots, and use integers or fractions for any numbers in the expression. So if we were to get a decimal, they don't want to see the decimal. They'd rather see a precise solution. We didn't get a decimal here, so we'll just type in the number 13 and see what they say. All right, that's good. We'll move on. All right, well, how about this one? Now, in the last assignment, there was a discussion of properties of logarithms, and hopefully you picked up on that with the problems that you were working through. And very briefly, before we left for our homeschool instruction, I talked about ways to combine logarithms that contain the same base. It was a real quick discussion, and unfortunately, I don't know, or I didn't emphasize that too much before we went away. But here's a chance to see this in action. Since the instructions here are telling us not to include decimals, we have to use integers or fractions for our answers only. The recommendation from MathXL and myself too is to combine these two logarithms, which can be done since the two logarithms have the same base, but combine these two logarithms before you actually solve them. So let me take a minute here and copy this down. This is my question number 6. We've got log base 7 of 3, which even if I type that into a calculator, that one would come out to be a decimal, plus log base 7 of x, and all of this is equal to 0. Now, if you're carefully thinking about this, one thing you could do, and we're not going to, but one thing we could do is subtract log base 7 of 3 from both sides, minus log base 7 of 3 from both sides. And in this case, we would get lucky because of the 0 on the right-hand side. But because this is just a number, log base 7 of 3 is going to calculate to some number, we would essentially have a result here. Log base 7 of x is equal to the opposite of log base 7 of 3. And with a couple more tricks, we could find out what the solution is. But again, that's not the process that I'm suggesting here. But if you were thinking of that is a good thought. The suggestion that I am making here is to combine this logarithm with this logarithm through the process of addition. Now, when you're adding logarithms, because they're essentially exponential expressions written in a different form, we do have to be a bit more careful with this. It's not quite as easy as you might expect. There's one additional trick we've got to be careful of. The idea is this: when you're adding two logarithms with the same base, we can combine these arguments, these values inside the logarithm, but we combine them with multiplication. So these two get combined together with multiplication. So if I were to combine these two logs, they would actually end up looking like this. Log base 7, we keep the base of the logarithm evaluated at 3 times x is equal to 0. And now that we have a single logarithm, we can rewrite it as an exponential. 7 to the 0 power equals 3x. And then to get x by itself, we would divide by 3, divide both sides by 3. And for our final answer, we need 7 to the power of 0 divided by 3, because that's what would equal x. Now, 7 to the power of 0, if you forgot, is actually equal to the number 1. Anything to the power of 0 is equal to 1. And if we take that 1 and divide by 3, well, we get a decimal. And that's a problem because MathXL does not want a decimal solution. So instead, I'm going to take that 7 to the power of 0 and divide it by 3, but leave my result in the form of a fraction. So now, even though you may get the correct answer, 0.3 repeating, we know how it should be written into MathXL, which is 1 over 3. And pressing your divide key or slash key will automatically create a fraction in MathXL here. So 1 over 3, and I will check my answer here. And it looks like we've got a good result. I'm going to do one more example in this particular video, and then I'll move on to create a third one if necessary. Here again, we've got a logarithmic expression that's equal to a number, and solving that is going to be difficult because the unknown results are here. Unknown values are inside of the argument of the logarithm. So let's go ahead and write this down and rewrite it as an exponential. So log base 5 of x squared minus 4x is equal to 1. Let's double check that. Log base 5 of x squared minus 4x equals 1. Okay, so this is the expression in logarithmic form. We can very easily rewrite it as an exponential. 5 to the first power is equal to x squared minus 4x. 5 to the first power is just 5, so no surprises there. But we've got to rely on some old knowledge at this point. This is going way back to first semester. Anytime that we need to solve an equation that contains an exponent in it, a numerical exponent, this time the exponent's not a letter, but with a numerical exponent, then the goal is to get this equation equal to 0 and use some techniques to solve. Now this is a quadratic, so I'll probably use the quadratic formula or factoring to solve this, but again, we do have to go through the process of getting this equal to 0 first. So I'll subtract 5 from both sides of the equation. And now we've got 0 equals x squared minus 4x minus 5. And this is how we would continue to solve this particular problem. Now, this is factorable, and I recognize it. Some of you will recognize it as factorable, and it makes solving it quite easy. So I'm going to show this result first. 5 times 1 will equal 5, and if I use a negative 5 times a positive 1, that will multiply to make negative 5, and also negative 5 plus 1 equals negative 4. So as factors, we have the expression factored now, and if you recall, these factors can be set equal to 0. X plus 1 equals 0. and x minus 5 equals 0. So I would argue that after subtracting 1 on this problem and after adding 5 on this problem, we would have two solutions. X equals -1 and x equals 5. Now, if you had forgotten about the factoring technique, that's okay. We could have used the quadratic formula with a being 1, b being -4, c being -5. The discriminant is equal to the opposite of b plus or minus, oops, sorry, getting myself confused here. The discriminant, the portion underneath the square root sign, is b squared minus 4ac. So in this case, we've got -4 squared minus 4 times 1 times -5. So this is 16, and 4 times 1 times -5 is 20. So -4 times 1 times -5 is positive 20, which equals 36. So our discriminant is 36. If we solve the quadratic formula, then I'll go ahead and do it down here. X would be equal to the opposite of b plus or minus the square root of our discriminant divided by 2a. And this is where, again, we're referencing old content at this point. This particular process was practiced a bunch during first semester. But we've got the opposite of b. We said that b was -4, so the opposite of that is +4. Square root of 36, that's a nice number that we can find the square root of. And we're dividing by 2 times a, which is 1. So 4 plus and minus 6, because 6 is the square root of 36, we're dividing that by 2. We'll go ahead and split this up twice here, because 4 plus 6 is 10. 10 divided by 2 represents one answer, and 4 minus 6 is -2. -2 divided by 2 is the other answer, and we end up with 5 and -1. Just the same as what we saw a few moments ago. So now hopefully you can see why I prefer factoring whenever possible, because it tends to be a bit quicker, but the factoring technique doesn't always work, whereas the quadratic formula does. So if I jump back to MathXL, it says use a comma to separate answers as needed. So since we did get two results here, we'll go ahead and separate them with a comma. So I'll write -1, comma 5. These are the two results we expect to see. And sure enough, MathXL accepted them as an answer. So again, I'll stop the video here so that it doesn't get too long, and hopefully those help you out with this round of questions. Good luck.